Okay, quiz 15.1 has to do with equilibrium constants. And for all of these questions, or for questions 1 through 4, we're going to consider this reaction. N2 gas plus 2 O2 gas is in equilibrium with 2 NO2 gas. And the first question here, question 1, says to give the equilibrium expression Kc. Kc is going to equal the concentrations of products NO2 raised to the power of their stoichiometric coefficients. So the stoichiometric coefficient here is a 2, so we square the NO2, divided by the reactants N2 and O2 raised to the powers of their stoichiometric coefficient. So we'll square the oxygen, nitrogen just has the 1. Give the equilibrium expression Kp. That's the same thing but with pressures. So Kp is just going to be the pressure of NO2 squared over the pressure of nitrogen times the pressure of oxygen squared. Same thing, just with pressures. Give the relationship between Kc and Kp. Well, we know that Kp is equal to Kc times RT raised to the power of delta N. And that's the change in the number of moles of gas in the balanced chemical reaction. So here we have 1, 2, 3 moles of gas, and here we have 2 moles of gas. And so that means that delta N is equal to a -1. Delta N equals -1. And so Kp is equal to Kc over RT. RT raised to the -1 power is just dividing by RT. If we have a value Kc equal to 6.4 times 10 to the 9th, would you expect to find more reactant or product at equilibrium? Well, 10 to the 9th is a big number, and so it's much larger than 1. That means that there's a very large numerator and a very tiny denominator. And so we'll have a lot of NO2. That's the product. This will be a product-favored reaction. All right. Let's give the equilibrium expression Kc for the solvation of calcium nitrate. And so we have calcium nitrate in equilibrium with calcium 2 plus and NO3 minus aqueous, and there are 2 of those. And that means that Kc is going to equal our products, calcium 2 plus and NO3 minus, raised to the power of their stoichiometric coefficient, so we'll put a 2 there, divided by the reactants, but the only reactant is a solid, and it is left out of the expression. So this is actually it. For solvation reactions, you'll have this form for the equilibrium expression, just the products over, I guess, over a 1, right? There's no reactants to put down there. And then the next question, give an equilibrium expression for the reaction of HCl with water. So HCl is a strong acid. HCl aqueous plus H2O liquid will be in equilibrium with H3O plus aqueous plus Cl minus aqueous. Strong acids are just acids which have a highly product-favored equilibrium constant. They are still technically at equilibrium, and under certain extreme conditions, like really high concentrations, then then that equilibrium can become important. Anyway, we're going to end up with Kc is equal to the concentration of H3O plus times the concentration of Cl minus over concentration of HCl. Water is a liquid, and so it is absent from this equilibrium expression.